Section 9.2, we're going to learn how to do a hypothesis test or significance test about a population proportion. Okay, so we're going to look at that same example from last class with Coach Rivers and his free throw shooting. And so we want to know, is there convincing evidence at the alpha equals 0.05 level that Coach Rivers is exaggerating about his free throw skills? Okay, so these steps are going to look familiar. It's the same 4 steps that we did for confidence intervals in chapter 8. Okay, so first step is state. You need to state your hypotheses, both the null and the alternative, what significance level you're going to use, and any parameters that we're going to use. So it's going to be the same hypotheses that we used last time. So P is equal to, our null hypothesis is that P is equal to 0.8, and our alternative is that P is less than 0.8. And then we define our parameter. P is the true proportion of all free throws made by Coach Rivers, and our significance level is going to be alpha equals 0.05. Okay, then for the plan part, we have to check conditions. All right, so we're going to identify the inference method. We're doing a one sample Z test for P, and then check conditions. And these conditions are going to look very familiar. We have to have a random sample. Our sample has to be less than 10% of the population. And we have to meet that large counts rule. Now, a note on the large counts, okay? Because we are assuming the null hypothesis is true, we are going to use this P0 is the probability from the null hypothesis when we check the large counts. Okay, so we're not going to use P hat. We're not going to use our sample proportion. We're going to use the proportion from the null hypothesis. So in this case, it would be 0.8. All right, so we would do 50 times 0.8 and 50 times 0.2. And both of those have to be at least 10 for us to be able to do this test. All right, so then for our do part, there are 3 things you need to show. What is the sample statistic or statistics that you are using? What is the standardized test statistic, which we're going to talk about, and then what is the p-value, okay? So here's the math behind how we find what a p-value is, okay? So we are assuming that the null hypothesis is true, that the proportion of free throws Coach Rivers makes is 0.8. Okay, and so then the question is, what values of p hat in his sample of 50, what would we expect, right? Because we know they're not going to all equal exactly 0.8, but if we took a lot of different samples, what would that look like? Okay, and so because those 3 conditions are met, what we end up with is sort of a normal curve, all right, where the average is 0.8. And then the standard deviation, remember, this is our standard deviation for a sampling distribution. So we've seen this formula before. Okay, so it would look something like this, where if he took a lot of different samples of 50 shots, most often he would be right at 0.8 if that's the true value. And then some would be lower and some would be higher. All right, so this means we can use the properties of the normal distribution. We can use that normal CDF like we've been doing in numerous chapters so far. Okay, so when we get to our do part, things we need to identify. First is our sample statistics. So in this case, p hat, the sample proportion, is 32 out of 50, which is 0.64. Okay, then we have to calculate the z-score for a proportion of 0.64. Okay, so if you remember from way back, the formula for a z-score is x minus the mean divided by the standard deviation. All right, so x is going to be our sample statistic of 0.64 minus the mean of 0.8, because the mean is equal to the null hypothesis, divided by the standard deviation, and we would do the standard deviation of the sampling distribution like we've done before. Okay, so we do that and we get a z-score of negative 2.83. This number, this z-score, is also called, when we do it in this fashion, in this circumstance, is called a standardized test statistic. Okay, so it's the z-score. It's how many standard deviations are we away from the null hypothesis. So in this case, Coach Rivers making 32 out of 50 is 2.83 z-scores below the mean. Okay, and so then we would take that z-score and put it in that normal CDF in our calculator. The lower is just a really big negative number. The upper limit, because we're looking for 0.64 or lower, so the upper limit would be our z-score that we found, and then the mean is 0 and the standard deviation is 1, and that gives me 0.0023. That is the p-value, okay? Which we talked about before is the probability of getting a value of, in this case, 0.64 or lower. So the probability of getting our sample statistic or further away from the mean. Okay, so for the do part, we're looking at something like this. Give me the sample statistic, give me the z-score, which is also called the standardized test statistic, and then give me the p-value. All right, and we would be using our calculator to do the p-value because we haven't really done the table. Okay, your other option is to use your calculator. All right, the calculator will do the entire testing process for you. So I gave you the directions here, and I'm going to show you what it looks like on the screen. So if you're in a Casio, when you get to that test, the first thing it says is proportion, and you're going to choose the symbol that matches your alternative hypothesis. So in this case, our hypothesis was that p is less than 0.8. Okay, and then in here, we're going to put in the information. So the proportion that we're testing in our null hypothesis is 0.8, and then Coach Rivers made 32 out of 50 shots. Okay, and then the calculator will give you the three things that you need to write. So p hat is right there, 0.64. The value of the standardized test statistic, that's z. So z would be negative 2.83. And then the p-value, that's the p right there. This, remember, is scientific notation, so I move that decimal over 3 places and I get 0.0023, which is exactly what we got when we used this method, okay? On the TI, same idea, okay? Once you get to that screen, this is what it looks like, okay? And so it's the same thing as the Casio, just in a different order. So P0, our proportion from our null hypothesis. All right, Coach Rivers made 32 out of 50. And then again, I'm selecting the one that matches the alternative hypothesis. So you just use the arrows to go to the one you want and then press enter to select it. All right, and then calculate. And again, all three things that you need to write down: the p hat, the sample statistic, the z, the standardized test statistic, and then the p-value. All right, so if you're going to use the calculator, which I would recommend because it's just so much faster, but you have to make sure that you write down all three of these things. If you don't, you will not receive full credit either on our testing class or the AP exam. Okay, and then the last step is conclude. All right, and we're going to use that conclusion sentence that we talked about in 9.1. Okay, so because the p-value is less than or greater than, whatever it is, our alpha, in this case it's less than, we're going to reject or fail to reject the null hypothesis, and then we do or do not have convincing evidence that whatever your alternative hypothesis is. Okay, super important note here. Okay. When we have, this did not happen in this case. In this case, we rejected. But if you get a p-value that is greater than alpha and you are going to fail to reject, make sure that you only talk about whether or not there is convincing evidence for the alternative. Okay, so we can say there is or is not, or we do or do not have convincing evidence for the alternative hypothesis. Okay, we are not saying anything about the null other than reject or fail to reject. Okay, so if you write anything that, like, we can accept the null hypothesis, we have evidence the null hypothesis is true, anything like that is going to cost you points. Okay, we can only talk about whether or not we have evidence for the alternative, not the null. All right, and so now we're going to go through an example, and after each screen, it's going to pause for you to try and work through this by yourself. And then one last note, also in your conclusion sentence, make sure that you are talking about the parameter. So when we talk about saying we do or do not have evidence for the alternative hypothesis, we're giving that part of the answer in context. Make sure that your context is referring to the parameter and not the sample, okay? So it's usually very little things with the words, okay? But anytime we're doing significance tests, our hypotheses refer to parameters. So anything we write about has to also refer to the parameters. Okay, and that is it for 9.2.